The next type of excuse me, function that we will look at are the quadratics. Now, you would have seen the equation for the quadratic written like this, obviously with numbers in the spot for A, B and C. The only difference now is you might see that quadratic given the notation f of x. In terms of the graph, there's only two shapes possible for a quadratic function when we graph it. It's an up the right way U or an upside down U shape called a parabola. Now, in order to sketch, because remember we're making the connection between the algebraic form and the graphical form, there's a couple of ways you can go about sketching the graph. Drawing a table of values is very time consuming, and we have to make sure that we get the appropriate set of x values for our parabola to assume its full shape. So rather than do that, if you can think about these features of the quadratic, of the parabola, it will help you to draw the sketch. So one of the obvious features is which way will the parabola be shaped, up or down? And we can get that by simply looking at the value of A, or the sign of the A in the function, so the sign in front of the x squared. And you know that if that is a positive, you'll get this one, A has to be greater than naught, and you'll get this shape if A is if A is less than naught. If A is a negative, the parabola will be upside down. So knowing that is a very good way to start to get your sketch. Find the y-intercept. Find where the graph is going to cut the y-axis. Now we know that all the way up and down the y-axis, x is equal to naught. And this makes for a very nice equation for a quadratic, because this term's going to go to 0, this term's going to go to 0, and in fact your y-intercept is just going to be the constant term. Then moving on, so you can actually identify exactly where your parabola cuts your y-axis. Move on to find the x-intercepts, if they exist. Now, you may wonder why I'm saying if they exist. Well, it is actually possible to draw a parabola up here, and that's an example of a parabola where there aren't any x-intercepts. But what we know is that if there are x-intercepts, then they will occur along the x-axis, and along the x-axis y is equal to naught. Along the x-axis y is equal to naught, along the y-axis x was equal to naught. These are automatic things that you need to be recalling, having access to, so that you can build this picture of the graph. Now, if you think about it, we did a lot of work putting our quadratic ax squared plus bx plus equal to naught. Where did we do that? We did that when we were factorising. Why? Because we want to know the x values that give us this situation where the quadratic is equal to naught. How does that equate to the graph? Well, if there are x values that will make our quadratic equal to naught, they will be the x-intercepts of the graph. Hopefully you're able to see that the skills we learned back in the previous chapter on factorising, solving a quadratic equal to naught, are now the skills we need in order to graph the quadratic. And then when we are doing a much later chapter, drawing the graph of a quadratic, or any of these functions, is an essential step in, for example, being able to find the area between the curve and the axis. So these skills just keep building in order for you to master the next skill. If you're still having trouble with solving a quadratic equation equal to naught, then you will definitely have trouble drawing the graph of the quadratic. If you need more work on solving quadratic equations, then you have to find some extra time and address that, because you can't afford to be held back with sketching now just because you can't solve a quadratic equation equal to 0. Another important feature to put on the sketch of a quadratic on the parabola is the axis of symmetry that occurs at x is equal to minus b on 2a. Hopefully most of this is familiar to you. We will revisit the quadratic in a whole chapter, but the more that you can master now, the easier that chapter will be. And to find the vertex, you substitute this x value into, substitute this x value that you've just found it back into the equation up here, because this equation gives you the y value. So if you've got the x and the y you get from subbing into the function, then you've got the vertex. And so you're able to sketch the quadratic. I'll stop the video there. I'll do one of the examples and the rest I'm going to do with you in class.